We use voltmeters for measuring all kinds of quantities, both AC and DC. But there are some differences between the measurements. I'm going to talk about it from two perspectives, and one of them is physically what's different between taking the measurements, and then quantitatively what's happening differently inside the meter and why are these measurements different. In other words, why do I have to change to a different point on the meter when I'm measuring the exact same thing? So first, we'll talk physically. The difference between AC and DC measurements in terms of voltage are actually very similar. We want to measure the voltage either supplied by a component, like a battery or a power supply, or the amount of voltage dropped by a component, really any sort of load. To do this, we take two leads out of our meter, a red and a black, the common and the place where the voltage is input, and we connect it on both sides of the load device, and we measure our voltage. For that reason, both the AC and the DC voltage measurements are done in the same way. And in this case, there is no difference between the voltage measurement and other scales of voltage. DC is different because what I'll talk about in a second is that the measurements inside the device, the calculations that are happening, are different. So we need to have a different setting on the meter. In terms of current, we can measure current in line, which means we have to break open the circuit, put the meter into the circuit, and the electricity flows through the meter on its way to the load. Now, as you might imagine, that can be pretty dangerous for something that consumes a lot of current. What happens if there's too much current going through the meter? Couldn't it blow a fuse? Yeah, it absolutely can. That's why usually there's two different connection points. One of them says, in this case, 300 milliamps maximum. The other one says 10 amps maximum, and it can measure both DC and AC current, and there are different modes of current measurement. Microamps, milliamps, and up to 10 amps for each one of those quantities. But there's another thing that we can do with clamp meters, and this only happens in AC measurements. We can put the AC measurement, the conductor that's carrying a single AC signal, in the lead of the current measurement inside the clamp, and it will give us a readout of the current. This only works for AC. Now, there actually are some for DC that use a much smaller connection point, but it uses what's called a Hall effect sensor to measure DC current, non-contact. This one uses the same principle as a transformer, which allows AC to induce a voltage onto a coil of ferrous metal, which is what we're creating right here, and that turns into an induced voltage. It's still a non-contact measurement, but we don't have to break open the circuit. Why is that so good? Well, with an AC clamp meter, especially in an industrial setting, those currents can be tens or hundreds of amps. You don't want to be touching that or breaking open that circuit while it's live to get into that measurement. A really quick note on the difference between the quantities is in DC, the voltage is all the same, and therefore the current is all the same. We can get a really easy measurement. But in AC, it's constantly going positive, negative, positive, negative. What is it at any given time? Well, it doesn't really matter because it's always changing. What's the average? Maybe we should use the average measurement. Well, that's no good either because the average measurement would be 0. It's spending just as much time positive as it is negative. So what we use is a quantity called root mean square, which is the equivalent amount of energy supplied by an AC signal as would be supplied by a DC signal, giving us an equal working amount of voltage and current to figure out what's actually happening in our load device. Not at any given moment, not an average, but the root mean square, which is an equivalent amount to the DC quantity that would be required to produce the same amount of power. It's a little bit complicated, but it's a good thing that we have these meters to do all that translation work for us, and all we have to remember to do is choose the right setting on the display.